integral is basically this area plus this area. They cancel out, so it's going to be 0. Okay. Now let's find the fundamental component. So the fundamental, in order to find the, so this is like what we want to do. We want to say like f of t is equal to f0 plus a1 cosine of 2 pi over t plus b1 sine of 2 pi over t plus harmonics. These are the harmonics, right? Higher order harmonics. These are undesired, as well as the DC. These are undesired components that we have in this signal, right? Because the desired component that we want to have, it's gonna be something like this with the fundamental frequency, and this T is 1 over F frequency that we want, right? 60 hertz, 300 hertz, whatever frequency that we want. This is what we want. But this signal has the fundamental component. In addition to that, it has some higher order harmonics, right? So right now, I just want to find A1 and B1. Okay, so let's do that. A1, it's going to be equal to 2 over t integral from 0 to t of f of t. Let's actually do v so that you don't get confused with frequency. And we found that this is 0. The DC component is 0. So A1 is v of t times cosine of 2 pi over t dt. Okay. So my signal, it's constant for half period. It's Vd over 2 and negative Vd over 2 for the second half. So I'm just gonna break this integral into two integrals, 2 over t times integral of 0 to t over 2. From here to here, v of t is equal to Vd over 2, right? Times cosine of 2 pi over t dt plus integral from t over 2 to t. And from here to here, the signal is equal to negative Vd over 2 times cosine of 2 pi over t dt. Okay, so this is constant. We can take it out, so it becomes Vd over 2. Sorry, becomes Vd over t, because these 2's cancel out, right? Now, so if we take this one out, then we just like have to take the integral of a cosine, right? So the integral of cosine is sine, right? This coefficient, it gets reversed and inversed and it comes out. So like then we would just like have Vd over t times t over 2 pi sine of 2 pi over t times t from 0 to t over 2 plus, actually minus because it's a negative Vd, so minus sine of 2 pi over t times t from t over 2 to t. Okay, so this actually gets simplified. So we have VDC over 2 pi times sine of, so I'm just going to replace t with t over 2, it becomes sine of pi. Because if I replace t with t over 2, t's cancel out, 2's cancel out, sine of p minus sine of 0 minus sine of, again, replace t with capital T, so it becomes sine of 2 pi plus sine of pi. What is this? All of them are 0. All of them are 0. So this is 0. A1 is 0, so this is 0. Actually, I didn't need to do this, but I wanted to do it to remind you that if you have an odd function, which is the case here, the coefficients for cosine become 0. So this one is done. Now we found that A1 is 0. Let's do B1. B1, it's gonna be again 2 over capital T from 0 to T. I'm gonna do exactly the same thing that I did before. From 0 to T over 2, f of t sine of 2 pi over t, so it's gonna be Vd over 2 times sine of 2 pi over t times t dt plus integral of t over 2 up to t sine of 2 pi over t times t dt. Okay, again, I'll take Vd over 2 out, so it becomes Vd over t. Now, if I take this one out, integral of sine, it's, just make sure that everybody can see the whole thing. Integral of sine is negative cosine, right? There's a coefficient here, I'll take that one out. So it becomes Vd over t times t over 2 pi. Negative cosine of 2 pi over t times t when t changes from 0 to t over 2. And sorry, this one was plus negative Vd over 2 times sine of this, right? So this becomes plus, yeah, so because this negative and the negative from the integral, they cancel out, plus cosine of 2 pi over t